All right, so from your notes, it looks like you are trying to figure out what's on the KCNA exam.
The Kubernetes and Cloud Native Associate Certification Exam.
Exactly.
Only.
So this deep dive is going to be like your cheat sheet to the KCNA universe.
What's really cool about the KCNA is that it's meant for anyone who's just getting started with cloud native technologies.
Okay,
So you don't have to be an expert in Kubernetes yet.
gotcha.
Yeah, you can just be starting your cloud native journey, or if you just want to show that you get the basics, this is a great place to start.
So perfect first step for
Yeah.
anyone looking to get started.
Yeah.
What kind of stuff does it cover, though?
Well, the exam is actually broken up into 5 key domains.
Okay,
And these are kind of like the main parts of the cloud native world.
like levels in a video game.
Exactly like levels in a video game.
I like that.
So the first domain is container orchestration.
Okay.
And this one goes into how to manage scale and network containers
Yeah.
inside of a Kubernetes cluster.
Okay.
This is a big one. It's actually 22% of the exam. You'll need to understand things like container runtime security and how all the containers can talk to each other.
So it's all about being a conductor for your container orchestra.
Exactly.
What's the next level?
So the next level is cloud native architecture.
Okay.
And this one is more about the core principles
Okay.
of designing applications for the cloud.
Gotcha.
So things like making sure that your app can automatically scale up when you need it,
Okay.
using serverless functions,
Okay.
and the importance of open standards and community involvement.
That's awesome.
This one is about 16% of the exam.
Okay, so that's a big chunk.
Yeah.
What else?
Then you have cloud native application delivery,
Okay.
which is all about how you actually get your code into production.
Okay.
This is 8% of the exam.
Okay.
And it involves CI/CD pipelines, GitOps, and how to make deployments safer and faster.
Streamlining the software delivery conveyor belt.
Yes.
Okay, what's next?
Next, we have cloud native observability, which is all about being able to see what's happening inside your application.
Okay.
Like you have X-ray vision for your system's health and performance.
That's awesome.
It's about collecting logs, metrics, and tracing requests to see if there are any bottlenecks.
So you can see any problems before they become big problems.
Exactly.
I like it.
And this is another 8% of the exam.
Okay.
Tools like Prometheus are going to be your best friend here.
Okay, so what's the final level?
The boss battle.
Boss battle of the KCNA.
The final domain and the biggest one is Kubernetes fundamentals.
Okay.
This is a whopping 46% of the exam.
Wow, that's a lot.
Yeah, and it's all about understanding how Kubernetes works at its core.
Okay.
Like understanding pods, deployment services, and how they all fit together.
Wow. Okay, so Kubernetes fundamentals is like the heavyweight champion
It is.
of the KCNA exam.
Yes.
If I'm just starting out, where should I even begin?
Well, let's break down some of the core concepts that you'll encounter.
Okay.
These are going to be like your building blocks.
Perfect. Let's get back to basics.
So first up, we have containers.
Okay.
You can think of these as lightweight packages for your software.
Okay.
They have everything that an application needs to run. So
Mhm.
like the code itself and all the libraries and dependencies that it needs.
So like a meal kit delivery service.
Exactly.
You get everything you need in the box.
Yeah.
Awesome. But how do you actually create and run these containers?
Well, that's where a tool like Docker comes in.
Okay.
Docker's one of the popular choices for building, shipping, and running containers.
Okay.
It just makes it easier to package up your applications.
Okay. So Docker is like our sous chef in the kitchen, helping us prepare the meal.
Exactly.
But how do we manage a whole bunch of these containers?
Especially when things start to get really big.
Yeah, especially when they start to scale up.
That's where Kubernetes comes in,
Okay.
or K8s as it's often called.
Okay.
This is like the conductor of your container orchestra.
Uh-huh.
So it manages all those containerized applications. Make sure that they have enough resources,
Okay.
and it can scale them up or down as needed,
Uh-huh.
and even restart them if they crash.
Okay, so Kubernetes is the maestro keeping all the containers in harmony.
Yeah, it is.
We're building modern cloud-native applications. What does that even mean?
So one important part of that is microservices.
Okay.
And this is like breaking down your application into smaller independent services
Okay.
that can all work together.
Yeah.
So think of it like a team of specialists.
Uh-huh.
Each one is focused on doing one thing really well.
So instead of having one chef trying to cook the entire meal,
Yeah,
we have a team of expert chefs, each specializing in their own dish.
exactly.
That makes a lot of sense.
Yeah.
But how does all this tie into actually getting my application from my computer to the users?
Well, that's where CI/CD comes in.
Okay.
CI/CD stands for continuous integration and continuous delivery.
Okay.
You can think of this as a pipeline for your code,
Okay.
almost like a conveyor belt. It involves practices and tools that help you automate the process of building, testing, and deploying your code,
Okay.
making sure that it flows smoothly from development to production.
Okay.
And tools like Jenkins are really popular for setting up these automated pipelines.
So it's like having an automated kitchen where the ingredients, which are our code,
Yeah,
are constantly being prepped, cooked, and served to the diners who are our users.
that's a great way to put it.
Okay. Pretty efficient.
Yes.
But how do we keep track of all the changes and updates?
Well, that's where GitOps comes in.
Okay.
GitOps is a way of managing your infrastructure using code
Okay.
that's stored in a Git repository, just
Mhm.
like you would manage your application code.
Okay.
Imagine if your infrastructure was a recipe,
Okay.
and every change that you made was carefully documented
Yep.
and versioned
Okay.
so that you could track every modification
Gotcha.
and easily roll back if something went wrong.
So it's like having a detailed recipe book
Yeah,
for your infrastructure.
exactly.
That makes sense.
So tools like Argo and Flux help you implement these GitOps principles.
Okay, so if that new spice blend in the recipe doesn't work out,
Right.
we can easily roll back to a previous version.
Yeah.
Cool.
It's all about bringing the same discipline to managing infrastructure as you do to managing application guard.
Okay, so we've covered containers, Kubernetes microservices,
Sure.
CI/CD,
Yeah.
and GitOps.
That's a lot.
That's a lot of ingredients in our cloud-native kitchen.
It is.
But how do we make sure that everything is running smoothly
Right.
and that we can spot any problems?
Yeah, before they impact our diners.
Exactly.
Well, that's where observability comes in. It's like having sensors all over your kitchen.
Okay.
Monitoring the temperature of the ovens,
Yeah.
the pressure in the gas lines,
Right.
and the flow of ingredients.
Gotcha.
It just helps you see how your system is behaving,
Yeah.
spot any bottlenecks,
Uh-huh.
and make sure that everything is running smoothly.
So observability is like having a high-tech control panel for our cloud-native kitchen,
Exactly.
where we can monitor all the critical metrics.
Yeah.
What are those metrics exactly?
Well, these are like the vital signs of your application.
Okay.
So things like CPU usage,
Okay.
memory consumption,
Uh-huh.
request latency,
Okay.
or the number of errors that are being logged.
Gotcha.
By tracking these, you can get a really good picture of how healthy your application is.
So it's like having a heart rate monitor for our application.
Yes.
We're making sure it doesn't overexert itself.
Right.
I like it.
Now, how do we actually collect all this data, though?
Yeah, how do we analyze it?
Well, that's where tools like Prometheus and Grafana come in.
Okay.
Prometheus is a really popular open source monitoring and alerting toolkit
Okay.
that's specifically designed for cloud-native environments.
Uh-huh.
It's great at collecting these time series metrics that we just talked about.
Correct.
Grafana, on the other hand, is a really powerful visualization tool that you can use to create dashboards and graphs from all that data.
Gotcha.
Just makes it much easier to spot any trends, anomalies, or problems.
So Prometheus is like our meticulous data gathering chef.
Yes,
And Grafana is our creative pastry chef,
exactly.
turning those numbers into beautiful, insightful visualizations.
It's a perfect pair.
I love it.
They work together to give you this really deep understanding of your system's health and performance,
Oh,
which can help you make smart decisions about how to scale and troubleshoot and optimize your applications.
So we've got our containers, cooking Kubernetes, conducting our microservices, specializing
Yeah?
CI/CD, delivering GitOps tracking, and observability monitoring.
Yeah,
It's a well-oiled cloud-native machine.
that it is.
But are there any common pitfalls
Uh-huh.
or misconceptions
Yeah.
that people often stumble on
Yeah, absolutely.
when they're getting started with cloud
Yeah.
native?
What are some of those?
Yeah. So a really common one is that Kubernetes is only for large companies.
With complex infrastructure.
I've heard that.
That's just not true anymore.
Okay.
While large companies have embraced Kubernetes, it's actually becoming more and more accessible
Okay.
to smaller teams
Uh-huh.
and even individual developers.
Cool.
There are managed Kubernetes offerings from cloud providers.
Right.
Like AWS, Google Cloud, and Azure
Yeah.
that abstract away a lot of the complexity.
Okay.
So it's much easier to get started.
So it's not just for the big leagues.
No!
Anyone can join the Kubernetes party.
Exactly.
Awesome. What's another myth that we can toss in the compost bin?
Another one is that cloud native is too complex.
Okay.
It's just too hard to learn.
Yeah.
And that's understandable. There's definitely a learning curve.
Yeah.
But the tools and services are constantly evolving to
Right.
make things simpler and more
Mhm.
accessible, even to smaller teams.
Yeah. I feel like that's true about anything new in technology.
Yeah.
Things start off really complex, and then as they get more adoption,
Yeah.
they get simpler and easier to use.
Exactly.
Awesome. So what's another myth?
Another common myth is that if you're going cloud native, you have to use serverless for everything.
Okay.
Now, while serverless is a powerful tool in the cloud-native world,
Yeah.
it's not the only option,
Okay.
and it's not always the best option.
Okay.
So you can still use containers
Yeah.
and even virtual machines
Uh-huh.
and still be considered cloud-native,
That makes sense.
as long as you're following those core principles
Yeah.
of agility, scalability, and resilience.
Gotcha. So you can mix and match different technologies and approaches
Right.
to find what works best for your specific needs.
Yeah.
That's awesome.
Now, one of the things that can be really helpful when you're learning about cloud native is to use memory aids
Yeah.
to remember all these concepts.
Absolutely. Like what?
So, for example, you can think of Kubernetes as the conductor of an orchestra.
Okay. I like that.
Right, just like a conductor leads an orchestra.
Yeah.
Kubernetes orchestrates all your containers.
Uh-huh. Make sure they're all playing together in harmony.
Exactly.
Okay.
Another one is you can think of microservices as a team of specialists.
Yeah, like we were talking about earlier.
Yeah.
That's a good
Yep.
word.
And then you can think of CI/CD as a conveyor belt,
Yeah.
where your code moves through the pipeline
Uh-huh.
and it gets built, tested, and deployed automatically.
So it's all about finding those analogies that make these complex concepts easier to understand.
Exactly.
Okay, those are really good.
Yeah.
So what does all this mean for someone prepping for the KCNA?
You know, it's more than just memorizing facts.
Right.
It's really about grasping those core principles of cloud native
Mm.
and understanding how these technologies all work together in the real world.
Yeah. And how to apply them
Right.
to solve real-world problems.
Yeah.
I like it.
And remember, cloud native is a journey.
Yeah.
It's not a destination.
Not a one-time thing.
Right.
It's constantly evolving.
Yeah.
Yeah. You always got to keep learning and experimenting
Exactly.
and not be afraid to dive deep.
Right. Welcome back to our deep dive on the KCNA.
We're picking up where we left off, exploring the fascinating world of cloud-native technologies and prepping for that KCNA exam.
Right. Last time we were talking about containers being at the heart of cloud native with Kubernetes orchestrating all those containers.
Yeah. We also talked about how Kubernetes and cloud-native in general are not just for those big companies.
Right.
And that serverless isn't the only option.
Yeah, it's not the only way to go.
Plus, we talked about all those other cool things like microservices, CI/CD, and GitOps.
Yeah, all those key ingredients.
All those key ingredients in our cloud-native kitchen
for modern apps.
for modern apps.
Okay.
Okay, so today...
Today, let's zoom in on some of the more nuanced concepts within Kubernetes.
Okay.
Those little details that can make a real difference when you're designing apps at scale.
Okay, so let's level up those Kubernetes skills.
Exactly.
One thing that always trips me up is the difference between deployments and pods.
Okay.
They seem connected, but I'm never quite sure how.
That's a really common point of confusion for people getting started with Kubernetes.
Okay.
Think of a pod as the most basic unit in Kubernetes, like a single building block.
Okay.
It usually runs in a container,
Okay.
and then a deployment manages a whole bunch of identical pods.
So if a pod is like an apartment unit, a deployment is like the entire apartment building.
Exactly. And deployments let you control how many copies of your pod you want running,
Okay.
how to update them, and how to roll back to a previous version.
Okay, so if I define a deployment,
Yeah.
I'm basically saying I need 5 of these pods running at all times.
Right.
And if one crashes, replace it immediately.
Exactly. You're defining that desired state.
Okay.
How many pods you want, what container image to use, what resources they need,
And Kubernetes just makes it happen.
and keeps it that way.
It's like having this army of tiny robots.
Yeah.
It's constantly making sure everything is running as it should.
That's one of the great things about Kubernetes. It takes care of all that, so you can focus on other things.
Awesome. So now, while containers are like the stars of the show in Kubernetes,
Right.
they're not the only actors.
Right. Kubernetes is actually becoming more and more versatile
Okay.
and can actually handle different kinds of workloads now,
Oh, okay.
like virtual machines and serverless functions.
Wait, so Kubernetes can manage things other than containers?
Yeah. So for virtual machines, you can use something like KubeVirt
Okay.
to run VMs directly within your Kubernetes cluster.
So if I had some old legacy applications
wait.
that were still running in virtual machines,
Uh-huh.
I could potentially move those to Kubernetes
You might be able to.
without having to containerize them first.
Right. In some cases, yes.
It's like building a bridge
Yeah.
between the old world and the new world.
Exactly.
Cool.
Cool.
What about serverless functions?
So for serverless functions, there are tools like Native and OpenFies
Okay.
that let you run those functions on Kubernetes as well.
So Kubernetes is becoming like the United Nations of workloads.
Yep.
Bringing containers, VMs, and serverless functions together under one roof.
That's a great way to put it.
Okay, I like it, and it makes sense.
Yeah, it's evolving to be the operating system for the cloud.
That's cool.
Uh,
Okay, so let's talk about networking in Kubernetes.
okay.
Networking has always felt like a black box to me.
Yeah, networking is super important in any system where you have things that are spread out,
Uh-huh.
and Kubernetes networking is really powerful, but it can be a little bit tricky to
Yeah.
understand at first. The main thing you need to understand is that every pod in a Kubernetes cluster gets its own IP address.
So it's like each pod has its own phone number.
Exactly.
Yeah.
They can call each other directly,
Okay.
no matter where they are in the cluster.
And Kubernetes handles the routing
Right.
to make sure those calls get connected,
Yeah.
even if the pods are on different machines.
Yeah, it's like having a super smart switchboard operator
Right.
who can connect any two pods in an instant.
That's really cool. But what about when I need to connect my applications to the outside world?
Right, like to users on the internet.
Yeah, to users on the internet.
That's where services come in.
Yeah.
We talked about them a little bit earlier.
Well,
But they're super important for making your apps available to the world.
okay.
A service is like a front desk receptionist.
Okay.
It provides the single entry point for accessing a group of pods that run your app.
So instead of having users call each pod directly,
Right.
they can call the service.
Uh-huh.
And the service will forward that call to one of the pods.
Exactly. And services can do a lot of smart things like load balancing,
Okay.
where they distribute the incoming requests
Okay.
across multiple pods.
So no single pod gets overwhelmed.
Right, so if one of the pods is taking a lunch break,
Yeah.
the service will forward the call to another available pod.
To make sure there's no interruption.
Right, and there are different types of services,
Okay.
depending on what you need. You have cluster IP services, which are only accessible from within the cluster.
Okay, so like internal phone extensions?
Yeah, exactly like that.
Okay.
And then you have node port services,
Okay.
which expose your service on a specific port on each node.
Okay, like a dedicated phone line for each department?
Yeah, that's a good way to think about it.
Okay.
And then if you want your app to be accessible from the outside world,
Yeah, so like a public website.
like a public website,
Okay.
that's when you would use a load balancer service.
Okay.
This type of service works with your cloud provider's load balancer
Uh-huh.
to give you this powerful entry point
Okay.
for your application.
That makes sense.
Distributing traffic across multiple pods, sometimes even across different regions.
So it's like a global call center.
Right.
Routing calls to the nearest available representative.
Exactly.
That makes sense. Okay, so what else?
Kubernetes has something called Ingress,
Okay.
which is a super smart routing system
Okay.
for your cluster. It lets you define rules for how traffic should get directed
Okay.
based on things like the incoming host name or the URL path.
So instead of having just one main entrance for everyone,
Yeah.
we can have multiple doors,
Right.
each leading to a different part of the application.
Exactly. For instance, you could have one rule
Okay.
that says all traffic
Right.
for shop.mywebsite.com
Yeah.
goes to your e-commerce service.
Okay.
And another rule that says all traffic for blog.mywebsite.com
Mhm.
goes to your blogging service.
That makes a lot of sense.
It's like having a receptionist that can send visitors to the right department.
Based on what they need.
Exactly.
Okay. And what else can you do with Ingress?
You can also do things like SSL termination,
Okay.
where you can offload all the work of handling encrypted traffic
So,
to the Ingress controller.
which makes things a lot simpler
Here.
for the individual services.
Exactly.
Cool. Okay, so Kubernetes networking is making a lot more sense now.
Yeah.
We've covered pods talking to each other, services acting as our receptionists,
Yeah.
and then Ingress as our intelligent routing system.
Yeah, that's a great way to put it.
What else should we know about keeping those cloud-native apps running smoothly?
Well, let's talk about storage.
Okay, let's unpack storage.
Yeah, so we touched on this a bit earlier,
Right.
but it's a really important part of any Kubernetes deployment.
Okay, but I thought containers were designed to be really lightweight
Right.
and kind of ephemeral,
Uh-huh.
so they don't usually store data permanently.
Right.
So how do we handle data that needs to stick around?
Right. That's where persistent volumes come in.
Okay.
These are chunks of storage
Okay.
that you can attach to your pods.
Yeah.
And they give your apps a place to store data even if the pod itself gets deleted.
So it's like having an external hard drive that
Yeah.
we can plug into our pod
Right.
to give it some extra space.
Yeah. And those persistent volumes can be backed by all sorts of different storage providers,
Okay.
like cloud storage services, network attached storage, or even local disks on the nodes themselves.
We've got options. But how do we actually manage those persistent volumes
Yeah.
and make sure that they're set up correctly?
Right. Kubernetes actually makes that really easy with
Right.
something called storage classes.
Okay.
Think of these as blueprints for defining the different types of storage that you need.
Okay, so I could have one storage class
Uh-huh.
for super fast SSD-backed storage
Yeah.
for those applications that need the best performance.
Uh-huh.
And then I could have another one for slower, cheaper, hard disk-based storage
Exactly.
for those workloads that aren't as demanding.
Right. It's like having different storage plans,
Okay.
each with its own price and performance characteristics.
Okay, I like that. But how do I actually request a persistent volume for my application?
Okay.
Do I have to manually create one each time?
Nope. Kubernetes uses something called persistent volume claims,
Okay.
which are essentially requests for storage. You just specify the storage class that you want and the amount of storage that you need,
Uh-huh.
and Kubernetes takes care of the rest.
So it's like placing an order
Yeah.
for storage,
Yeah.
saying what kind I need and how much.
Exactly.
And Kubernetes goes and shops for the perfect match for me.
It's like having a personal storage shopper.
I like it. It simplifies things.
Yeah, it really does.
Okay, so we've got persistent volumes for storing our data.
Right.
But what about configuration data?
Okay.
Things like database connection strings, API keys,
Right.
or other settings that our applications need to run.
Right. Kubernetes actually has a great feature for that called config maps.
Okay.
A config map is basically a dictionary,
Okay.
a collection of key value pairs
Mm-hmm.
that you can use to store configuration data.
So instead of hard coding those settings directly into my application code,
Right.
I can store them in a config map
Yeah.
and inject them into my pods as needed.
That's exactly it.
Okay.
You create a config map to hold those connection strings, API keys,
Uh-huh.
and other things.
Okay.
And then you can either mount that config map as a volume
Oh.
inside your pod,
Yeah.
making those settings available as files, or you can just inject them directly as environment variables.
So it's like having a separate recipe book
Yeah.
for our application,
Right.
storing all those secret ingredients and techniques
Right.
that make our dish unique.
That's a great way to think about it.
Okay. And just like our real recipe book,
Uh-huh.
we can update the config map, and those changes will be automatically reflected in our app.
Yeah, without having to rebuild or redeploy.
It's pretty efficient.
That's the great thing about config maps.
Okay, so we have persistent volumes
Yeah.
for our data,
Oh.
config maps for those configuration settings.
Yeah.
But what about secrets?
Okay.
Sensitive information like passwords,
Right.
API tokens,
Yeah.
or other credentials that we don't want to expose in plain text.
You're right. Security is super important. And Kubernetes has something called secrets
Yep.
to store and manage that kind of sensitive information.
Okay.
They are similar to config maps
Huh.
in the way they're used.
Uh-huh.
You can mount them as volumes or inject them as environment variables,
Okay.
but they're handled differently to be
Yeah.
more secure.
So instead of writing those secret ingredients directly on our recipe cards,
Yeah.
we now have a special vault to keep them safe and protected.
Exactly.
Tell me more about these secrets.
Kubernetes secrets are base 64 encoded by default.
Okay.
It gives you this basic level of obfuscation.
Okay.
It's not true encryption, though.
Okay.
It's more like hiding your secret ingredient in a locked cabinet.
Okay.
It's better than leaving it out in the open,
Right.
but someone who's really determined could still get to it.
So we should treat secrets with care
Yeah.
and consider some extra security measures.
Right.
Like using a dedicated secrets management tool for stronger encryption.
Exactly. And Kubernetes can work with those tools really well.
So it's like having a high security vault
Yeah.
within our cloud native kitchen.
Exactly.
Okay, cool. So we've covered a lot of ground today, from deployments and pods to networking storage
Yeah.
and even secrets management.
A lot
I
of
feel like we're starting to get a handle on the inner workings of Kubernetes.
good. We're making good progress.
And remember, Kubernetes is just one piece of the larger cloud-native ecosystem.
Right.
There's a whole world of tools and technologies out there
Right.
that all work together to create this cloud-native environment.
Exactly.
So Kubernetes is like the foundation of our cloud-native skyscraper,
Yeah.
but we need a whole bunch of other components to
Or-
build the rest of the building.
Yeah, you need tools for networking,
Okay.
storage monitoring, security.
And the best part is those tools are constantly evolving.
Exactly.
So it's a dynamic landscape.
Yeah, it is.
How do you keep up with all that?
The most important thing is to really understand the core principles of cloud native.
Yeah.
Things like agility,
Mm-hmm.
scalability, and resilience.
Okay.
These are the things that will guide you.
Okay, so those core principles are like our compass,
Yeah.
guiding us as we explore all these different tools and technology.
Exactly.
That makes sense. What else?
Don't forget about the community.
Okay, the cloud native community.
Yeah, it's so welcoming and helpful.
Yeah.
There are so many resources out there.
Yeah.
Forums, Slack channels, meetups,
Okay.
all these places where you can connect with others,
Yeah.
ask questions,
Yeah.
share your experiences, and learn from each other.
So it's like a global study group,
That's a great way to put
a
it.
whole network of supportive peers who are on this journey together.
That's great.
Okay, so we've been talking about the tech side of cloud native,
Mm-hmm.
but I've also heard that it's not just about the tech.
Right.
It's also about some cultural and organizational changes.
That's really true.
Can you elaborate on that a little bit?
Yeah, so it's really about breaking down those walls
Okay.
between development and operations teams
Yeah,
and creating a culture of shared responsibility
Okay.
and collaboration.
I like that.
It's about embracing automation,
Uh-huh.
streamlining your processes,
Okay.
and empowering teams to work faster and more efficiently.
So it's not just about adopting those new tools.
Right.
It's about changing the way that teams actually work together
Exactly.
and how they approach software development.
That's right.
Okay.
It's as much about the culture as it is about the technology.
That's starting to make a lot more sense now.
Yeah.
Okay, so we've covered a lot of ground today,
Yeah, we have.
diving into deployments, pods,
Uh-huh.
networking storage, and even secrets management.
Yeah.
We even touched on the importance of that broader cloud-native ecosystem
Right.
and the cultural shifts that are needed to really embrace this new way of working.
Yeah.
And we've only just scratched the surface.
Yes.
We've only just scratched the surface.
There's so much more to learn,
Right,
but this is a great starting point.
for sure.
And in the next part,
Okay.
we're going to explore even more advanced concepts
Okay.
that will help you solidify your understanding and really nail that exam.
Awesome. So stay tuned for the final part of our KCNA deep dive.
Yeah.
Welcome back to our KCNA deep dive.
Yeah, we're in the final stretch of our exploration of the KCNA,
Okay.
equipping you with the knowledge to conquer that exam.
I'm ready.
In the previous parts, we laid down a solid foundation,
Right.
covering things like containers,
Right.
Kubernetes,
Yeah.
networking,
yeah.
storage, and even the cultural shifts you need to thrive in a cloud-native world.
Yeah, it's been quite the journey,
It has been.
but I feel like I've learned a lot.
Good.
Okay, so now what?
So now it's time to level up even further
Okay, let's do it.
and explore those advanced concepts that will set you apart as you're getting ready for the KCNA exam.
Okay, unlock those expert level skills.
Let's start with self-healing,
Self-healing.
one of the best features of Kubernetes.
Okay, I've heard that Kubernetes can automatically recover from failures,
Uh-huh.
but how does that actually work?
Right? It sounds almost magical.
Yeah.
But it all comes down to those control loops that we talked about earlier.
Okay.
Remember, Kubernetes is always watching the state of your cluster,
Right.
making sure it matches the desired state.
Yeah, so it's like a vigilant guardian.
Exactly.
If a pod crashes
Yeah.
or a node becomes unavailable,
Yeah.
Kubernetes jumps in
Yes,
and brings everything back to that desired state.
that's right. So for example, if a pod crashes,
Yeah.
Kubernetes will restart it automatically
Okay.
on a healthy node.
Gotcha.
And if a whole node fails,
Yeah.
the pods that were running on that node will be moved to other available nodes.
So our apps stay up and running.
That's the goal.
It's like having an invisible repair crew
Yes.
constantly working behind the scenes to,
Right,
to
yeah.
keep everything running smoothly.
Exactly.
And we don't even have to do anything.
That's the beauty of it.
Okay, so this self-healing capability is what makes Kubernetes so reliable,
That's a big part of it.
like a built-in safety net
Yes.
for our applications.
Yeah, it's
I
that.
like it. Okay, so what else should we know to really master Kubernetes?
So scaling is another critical piece.
Scaling.
Yeah.
Oh.
You know, in the cloud,
Uh-huh.
being able to scale up or down as needed
Right.
is so important.
Because we don't want to be paying for things we're not using.
Right. You want to be efficient
Yeah.
and manage your costs.
But we also need to be able to handle those sudden surges in traffic
Exactly.
without our application crashing.
Right. You have to be able to adapt
Yeah.
to those changing demands.
Okay.
And Kubernetes has really powerful features
Okay.
for scaling both your applications
Yeah.
and the infrastructure underneath them.
Okay, so how does scaling actually work in Kubernetes?
It's actually more straightforward than you might think.
Okay, good.
There are two main approaches. The first one is manual scaling,
Okay.
where you directly control how many copies of your pods are running.
Okay, so if I need to handle more traffic, I can just tell Kubernetes, hey, spin up some more copies of this pod,
Yes.
and it'll distribute the load.
Yes, it'll spread the work out across those instances.
It's like calling in reinforcements
Exactly.
when the app is under attack.
That's a great analogy.
Okay, and what's the other approach?
So the other approach is automatic scaling.
Automatic scaling.
And that's where the horizontal pod autoscaler comes in,
Okay.
or HPA for short.
Great PO.
Yes.
Okay.
And the HPA is like this intelligent autopilot
Oh.
that can adjust the number of pods based on what's happening in real time.
Oh, that's pretty cool. Tell me more about this HPA.
So the HPA lets you set up rules based on all sorts of metrics, like CPU usage, memory consumption,
Okay.
or even custom metrics that you define yourself.
Oh, cool. So I can tell the HPA, like, if my CPU usage goes above 70%, start scaling up by adding more replicas. So it's like having a thermostat
Yes.
for our app
Okay.
that's automatically adjusting the temperature, which is the number of pods.
Based on the heat or resource utilization.
Exactly.
That's a great way to think about it.
And it works the other way, too.
Yeah. So if the resource utilization goes down, HPA will scale down the number of pods
To save money.
to save money on those unused resources.
That's a smart energy saving system
Yes,
that turns off the lights when no one's in the room.
exactly.
I like it.
It's very efficient.
Okay, so the HPA takes all the guesswork out of scaling.
It does.
My app can handle those traffic fluctuations
Yes.
without me having to constantly monitor it.
Right. And you can stay within budget.
Okay, that's awesome.
Yeah.
But what about scaling the actual infrastructure,
Okay.
the Kubernetes cluster itself?
Right.
What if I need to add more machines to my cluster to fit all these extra pods?
So for that, we have something called the cluster autoscaler.
The cluster autoscaling.
Yes.
Okay.
And it's similar to the HPA. Okay.
But instead of scaling pods, it scales the nodes in your cluster.
So if all my nodes are full
Right.
and I need more space for these new pods,
Yes.
the cluster autoscaler will automatically provision new nodes.
That's right.
It's like having a construction crew on standby,
Yeah.
ready to expand my cloud-native city
Yes.
whenever I need more space.
That's a great way to think about it.
Okay, so it integrates with my cloud provider
Uh-huh.
to spin up those new virtual machines
Yes.
that form the foundation of
Right.
my cluster.
Exactly.
So my infrastructure is elastic.
It is.
It can grow and shrink
Yes.
based on what my applications need.
That's one of the great benefits
Okay.
of using Kubernetes.
Awesome. Okay, so we've tackled self-healing
Uh-huh.
and scaling,
Yes.
two crucial concepts
Very important.
for anyone working with Kubernetes.
Yes.
What else do we need to cover before we jump into the KCNA exam itself?
Let's talk about security.
Okay, security.
Super important.
Yeah. In any cloud-native environment, you
Yeah.
can't just add it as an afterthought.
Yeah, it's got to be part of the plan from the beginning.
Yeah, baked in from the ground up.
So it's not just about locking the front door.
Right.
We need to secure the entire building.
Yes, from the foundation to the roof.
Exactly.
Yeah.
Okay, so how do we do that with Kubernetes?
Well, luckily, Kubernetes provides you with this layered security model
Yes.
that lets you implement security at multiple levels.
Okay,
Okay.
layers. Tell me about these layers.
So at the infrastructure level,
Okay.
you have things like network security groups
Okay.
and firewalls.
Wow.
They act as your first line of defense.
So we're securing the perimeter
Exactly.
of our cloud native city.
Yes.
Only authorized traffic can come and go.
You want to be in control
Yeah.
of who can access your cluster and what type of traffic is allowed.
Makes sense. Okay, and then what?
And then at the cluster level,
Okay.
you have things like role-based access control or RBAC.
RBAC.
Yes. Which lets you define very specific permissions
Okay.
for your users and service accounts.
So I can say which users have access to which resources
Uh-huh.
and what they can do with them.
Exactly. And what actions they're allowed to perform.
It's like having security clearance levels
Yes.
within our organization.
That's a great analogy.
Okay, cool.
So you can create roles like admin or developer or viewer,
Okay.
and then you assign those roles to different users.
So they can only do what they need to do.
Exactly. You're enforcing the principle of least privilege.
Okay.
You're only giving them the access they need.
Which minimizes the damage
Yes.
if an account gets compromised.
Exactly.
Much better than just letting everyone run around with full admin access.
Much better.
It sounds like the disaster waiting to happen.
That's right.
Okay, so we have the infrastructure level,
Uh-huh.
the cluster level.
Right.
What about securing those individual containers?
Right. Those individual containers running your apps.
Yeah.
That's where pod level security comes in.
Pod level security.
Yes.
Okay.
You can use things like security contexts
Okay.
and pod security policies
Okay.
to control how secure your containers are.
So can I say, like, whether or not containers can run with root privileges?
Yes, you can set those ground rules
Okay.
for how containers should behave.
Yeah.
You can define what capabilities they have
Okay.
and what security profiles they should follow.
Okay, so Kubernetes gives us all these tools
It does.
to control security at different levels.
Uh-huh.
But what about securing the actual applications themselves?
Okay.
Are there any cloud-native best practices?
Right. Even though Kubernetes provides a secure foundation,
Yeah.
you still need to apply those application security best practices
Okay.
that we've always used.
So those fundamentals still apply,
Yes, very much so.
even though we're building and deploying apps in a different way.
Exactly. So things like validating your inputs,
Okay.
encoding your outputs,
Mhm.
writing secure code,
Yeah.
and proper error handling are super important. Okay.
You also need to think about how your apps talk to each other,
Yeah.
how you manage your secrets,
Uh-huh.
and how you protect your data, both when it's moving around
That's
and
right.
when it's stored.
So we need a holistic approach.
Yes.
We need to secure both the platform
Uh-huh.
and the applications running on top of it.
That's right. It's like securing both the building and the people inside.
Exactly.
Okay, what
And
else?
don't forget about monitoring and logging.
Okay.
Those are super important for detecting and responding to any security incidents.
It's like having security cameras
Yeah,
so we can review the footage if
exactly.
something goes wrong.
That's right. Security is an ongoing process. It's a
Right.
journey, not a destination.
Okay, I'm feeling a lot more confident
Good.
about security in a cloud-native environment.
Good.
So we've covered self-healing, scaling,
Mm-hmm.
the different layers of security.
Yeah.
Let's talk about the KCNA exam.
Okay.
What resources are out there?
Okay, so the CNCF,
The Cloud Native Computing Foundation.
yes.
Okay.
They have a really comprehensive curriculum overview and a list of recommended training courses.
It's like a study guide
It is.
and syllabus.
Yeah, a clear path to success.
Awesome. What else?
There are also a ton of resources online, blog posts, tutorials, practice exams,
Okay.
and even open source projects.
That's awesome. It's like a vast library
It is.
of cloud native knowledge.
It is.
But with so much information,
Yeah.
it's kind of hard to know where to start.
All right.
Any tips for navigating all that?
The best way to learn is to get your hands dirty.
Oh,
Try setting up a Kubernetes cluster
cool.
on your own computer using tools like Minikube or
I get that,
deploy
yeah.
some apps, play around with them, break things.
Okay.
That's how you really learn.
So learn by doing,
Yes.
embrace those failures,
Exactly.
and iterate our way to success.
Yes.
What else?
Don't forget about the community.
Right, the cloud native community.
Yes, they're so supportive.
Yeah.
There are forums, Slack channels, meetups.
Okay.
You can connect with other Kubernetes folks,
Yeah.
ask questions,
Uh-huh.
share your experiences, and learn from others.
It's like a global study group,
That is.
a network of supportive peers,
Exactly.
all on this cloud native journey together.
Now remember, the KCNA exam is more than just passing a test.
Yeah.
It's about gaining valuable knowledge and skills to build and manage modern apps in the cloud.
So it's about investing in my future,
Exactly.
becoming a
Safa.
sought-after professional
That's right.
in this growing field.
That's right. The KCNA cert is valuable.
Yeah.
It shows you understand these principles,
Oh.
and it signals to employers
Yeah.
that you have the skills they need.
It's like earning my cloud native black belt,
That's a great way to put it.
a badge of honor.
Yes.
That sets me apart from everyone else.
And remember,
Yeah.
cloud native is a journey,
Yes.
not a destination.
Keep learning.
Keep experimenting.
Keep pushing the boundaries.
Yes, that's great.
Okay, that's really inspiring advice.
Good.
We've covered so much in this deep dive.
I know we have.
I feel way more confident about my cloud native journey now.
I'm so glad to hear that. Remember, embrace the challenge,
Okay.
have fun along the way,
Yeah,
and never stop learning.
that's a great note to end on.
Yeah?
We hope you've enjoyed this deep dive
We hope it's been helpful.
into the
And
KCNA
Elin, keep exploring
and keep diving deep.
into the world of technology.
Until next time.